The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone. Welcome to our webinar today, where you'll learn more about deploying Ignition with Moxa IIoT Edge Gateways. My name is Scott Siphon with Moxa, and I'll be your moderator. Before we get started, I do want to let you know that we had a slight change. Robert Jackson, one of our original presenters, actually had something come up last minute that required his attention. However, in place of Robert, we're lucky to be joined by Carrie Gunther, who is Moxa's IIoT Division Manager. So thanks to Carrie for stepping in last minute. Alongside Carrie, we're also joined by Travis Cox, Co-Director of Sales Engineering with Inductive Automation. Just a couple quick housekeeping comments before starting. If you have any questions during the webinar, please submit them through the questions pane, and we'll address them throughout the webinar or during the Q&A session at the end. Lastly, we will be sending a recorded version of the webinar to everyone who registered, so look for that tomorrow. With that said, I think we're ready to go. Let me hand things over to Carrie to kick things off. Carrie?
Perfect. Thank you, Scott. Yes, as you mentioned, I am pinch hitting here for Robert Jackson. Happy to do so. I thought I would actually Google famous pinch hitters to make a nice, funny joke as we started here. But as it turns out, there are actually no famous pinch hitters, so I suppose the joke is on me. But with that intro, appreciate it. My name is Carrie Gunther. I'm based in Austin, Texas, and I've been employed with Moxa, I think I'm going on 13 years now, and specifically working on IoT for roughly about 2.5 years. So let me go ahead and jump into the agenda here. First two bullet points I'll be covering. I'm going to go over the primary IIoT architectures that we see today with our industrial customers. And then I'm going to get into kind of the top 4 customer questions, concerns, areas that customers are frequently engaging us to ask more questions, and then how do we deploy one of these IIoT solutions. And then Travis is going to take the last 3 bullets here. He's going to review what we refer to as a modern SCADA architecture utilizing MQTT and a technology called Sparkplug. He'll then be going over deploying Ignition and some different benchmarking that we've done recently. And this is very exciting. I think this is the first public release of those benchmark statistics in Ignition Edge running on Moxa hardware. And then finally closing out with the announcement of Ignition 8 and some of the new software and features that the Inductive Automation team is going to be releasing, or I believe has officially released within the last couple of days. So with that, let me jump into primary architectures here. And I'll start with the background in that when Robert and I started thinking about how do we talk about IoT with our customers in a broad spectrum, we found it interesting that everybody has a different opinion of what IoT is, and then people want to implement an IIoT project, or they reach out for IoT information, and it can be very disparate in what exactly that customer has in mind. And so what we did is we tried to at least simplify 3 different primary architectures, and it is more complicated than that. We do see customers hop between these, and sometimes it's a combination. But if we talk about 3 architectures, we can at least start to identify common applications and common themes across those. So the first one, and I would say one that we see deployed probably the most frequently today, is what we just call edge to cloud. What that means is you have some equipment in the field, maybe a device, a sensor, your quote unquote thing, and you want to get data from that directly to the cloud. And that can go straight through a gateway, through some WAN connection, directly into a cloud database. And now that data that was living in the field has been sent from the edge directly to the cloud. The second one, and where we'll spend the most time today, is what we call edge to modern SCADA. And so companies like Inductive Automation have built new software and new platforms that actually allow the SCADA system itself to live in the cloud. It's a little bit different than necessarily a straight edge to cloud, because now you've got different things involved here to be able to do control and more automation type functions. We'll get into that quite a bit more here in the rest of the webinar. And then finally, we do have customers that are implementing IoT technology, but really it's on what I would say the back end of a traditional SCADA system. And so if you look in the bottom right-hand corner, nothing really changes with the SCADA architecture that's in place, but then that SCADA system is then linked in sending relevant data to the cloud, where you have a lot more compute power, cloud servers, and you can do very high-end analytics and machine learning and high computation in the cloud, but you're not really impacting the traditional SCADA system. If we look one step further, we start to outline the partner ecosystem, and this is where Robert Jackson has the role within Moxa as our global IoT partner manager. But even when we look at partners in the ecosystem, we try to categorize those different partners because there's a lot of different pieces to these solutions. So on the left-hand side, you see cloud platforms. I think this one is probably the most well understood. However, in a traditional sense, the cloud is where you can put your database. There's servers, and this is where the data lives. But the solutions from these partners are becoming far more complex than they have in the past. And partners like Microsoft and AWS and Google have actually created edge software as well. So even though we categorize this as a cloud platform, the software spans across many different parts of the architecture. In the middle, again, we're referring to online SCADA or modern SCADA. You can see companies such as PTC with ThingWorks, Wonderware, Spark Cognition, Inductive Automation. Travis will be covering a lot more of that in detail. And then finally, the industrial providers. And so these are companies like Siemens and GE and Emerson who make many different products, but they have very high-end analytic systems that know how to read that data and do the machine learning on the back end of all their equipment. So that brings us right to our poll question number 1. And Scott, if you don't mind bringing that on the screen, perfect, thank you. So the first question here is, what are the cloud or SCADA systems you are evaluating? I believe you can check all that apply. You might have more than one, but the options here: Microsoft Azure, Amazon AWS, Ignition by Inductive Automation, ThingWorks, or other. We'll maybe wait just a couple seconds here. And Scott, if you don't mind showing us the results. There we go. So good news for Travis, and obviously we're doing this webinar here with Inductive Automation, but it looks like a little bit over half of the attendees are currently evaluating Ignition by Inductive Automation, and then maybe a third with Azure, a third with AWS, roughly 12% on ThingWorks, and then another third in other. And I would say this is probably close to what I would have expected as the results, the nice thing with IoT is you're not locked into one solution. We even find many customers have a multi-cloud solution, and they'll have redundant setups, one in Azure, one in AWS, maybe one in Google. So great feedback, thank you. Okay, so let me move on to the second agenda topic here, and we can really get into a little bit more details into some of these IoT solutions. So top 4 questions for edge devices. Sorry, I needed to advance the slide there. So again, I've been doing this for quite some time, worked with many customers, and again, we try to do our best to categorize the different type of questions that come up when you look to select an IoT gateway or a smart edge device. First one is around edge connectivity. Second one is around rugged hardware, long-term support. Third being security. Many times this is the first question that gets asked because you are directly connecting OT systems into an IT environment, sometimes in a public cloud. And then the fourth one being the integration of those cloud architectures, and how does that work when you're bridging OT directly to IT in this single device. And so let me elaborate a little bit further into here. So the first question concern is around edge connectivity. This is an area that Moxa, quite frankly, has built over 3 decades of experience in what we historically would call protocol conversion. Now a lot of what was done in a single appliance as a protocol converter is transitioning into being done in software. Now some of this can be done in software, but some of this is still hardware-based protocol conversion. And so you have different protocols here that can be done in software over an Ethernet or serial connection, and some do require the hardware. So things like Modbus, both serial or Modbus TCP, Ethernet IP, Profinet, these are all Ethernet-based protocols that you can bring directly into that gateway. Then you have other devices or other protocols like Profibus or CAN. These are hardware-based protocols, and you do need specialized hardware. Some of those you would still do through a standalone gateway, but some of them we have started to integrate into the IoT gateways. So some of the new gateways that Moxa has been releasing actually add CAN ports to the device. And really, I think the nice thing in this edge connectivity is whether you're connecting to an Ethernet or a serial protocol or something more specialized like CAN or I/O, the gateway becomes that centralized point where you can bring all that data together. Second question or concern is around industrial hardware and long-term support. So industrial hardware is nothing new for Moxa, but a lot of times it is new in an IoT implementation. Many of our customers are deploying these in remote locations. They're going to sit in a metal or plastic box in the middle of West Texas. You're going to see extreme temperature environments. And so, yes, these are computers, but they're very specialized computers to run on low power, giving them a very long life that we can give a 5-year warranty around. But you need those temperature extremes, and you need those temperature extremes with all the various communication methods that are built into it. Going one step further, when we talk about a gateway, we'll very quickly try to help customers understand the right platform. Today, we split that out by processor type. So x86, those of you that are familiar with Intel based architectures such as the Atom or I-Series or Celeron, those are x86. That's going to give you a lot higher compute power. We do offer those. Those come with a Windows or Linux operating system. And then we also support an ARM series, and these are ARM-based processors. Typically not going to have near the performance that you have in x86, but much smaller, much more scalable, and these are all based on a Linux operating system. And speaking of Linux, that's the next topic here. So we talk about long-term support. We provide that both on the hardware level, but we also support long-term operating system support. Moxa will refer to this as a Moxa Industrial Linux. Really what that means is we're not creating a new operating system. We're based on Debian. We've recently transitioned from Debian 8 to Debian 9. But in a typical IT environment, Linux distributions are supported by the foundation for 2 to 3 years. Beyond that, the foundation moves to a new rev. So you'll go from 8 to 9 to Debian 10 to 11. It's very common practice in an IT environment. But for industrial IoT, if these are in a remote location, it's not necessarily that simple to go out and completely re-image the unit to a new Debian operating system. And so our customers come in and need a way to still ensure stability and security, but not have to re-image these gateways and have them running in the field for a long time without touching them. And so what Moxa offers is once the community has moved past the standard release and onto a new one, Moxa takes over for 7 additional years to provide those bug fixes and security patches over the life of that device. And so both the hardware itself and the software is designed for long-term support. Security. This is a rather simple slide here. And Travis is going to go into quite a bit more detail on security as it relates to transport protocols and more of the cloud connectivity side. But security is also something that needs to be viewed at the hardware level and at the very far edge. This could easily be an hour, 2 hour, 3 hour webinar by itself just focused on security, but just to give a little bit of an idea of what's implemented on the edge as it relates to security from a physical standpoint, there's things like TPM or Trusted Platform Module. This is a dedicated chip on the board of the computer that handles encryption keys. Moxa has also developed utilities that are based on the IEC 62443 standard, and this is a utility that will look at how you have that Linux environment set up and tell you if it's compatible with the 62443 standard that we're seeing adopted for cybersecurity. We also build things like a secure boot environment in that Moxa Industrial Linux operating system. And then finally, some of the newer technology coming out, things like Trust Zone or Root of Trust. This is actually taking the encryption and security, not just to a dedicated chip like TPM, but actually to the core ARM processor. And so some of the new products that are being released, we have newer NXP dual core ARM processors that allow us to start implementing Trust Zone and Root of Trust into the hardware itself. And then finally, we talk about cloud integration. What you see on the left-hand side here is the architecture where we discuss edge to cloud. And this is just an example. I had mentioned earlier that the cloud can certainly be seen as a data repository in a large facility. Servers in the cloud, it's just where you put data, but it's going much further than that now. And we work with companies like Microsoft that Moxa has partnered with to implement software services that actually run on the Edge Gateway itself. So new products like Azure IoT Edge. This is a rather complicated architecture, not complicated, but a lot of different pieces to it. I won't go into all the details, but the key here is connecting to the cloud is, it can be as simple as just pushing data into something like Azure's IoT Hub, but it's becoming far more elaborate now to implement security and different services that connect all the way out to the edge. And then finally, ThingsPro Gateway. This is another utility that Moxa provides to put a GUI onto the computer itself. So in a Windows environment, most of you are probably very familiar with how to configure your network, how to set up an IP address. But in a Linux environment, and especially for our OT customers, it's not that easy. There's not a GUI or a window to come in that you're familiar with to make those settings. And so Moxa provides a ThingsPro Gateway for device configuration. You can see CPU utilization here. We talk about upgrading the system. This is where you would import those patches or bug fix to the operating system. You can see IP settings here. So if you needed to set a static IP or DHCP or set up a DNS server, we give you a GUI and a utility where you can configure that. LTE, a lot of our customers are putting these in distributed networks that are communicating over cellular. There's a built-in GUI to see your signal strength, to put your APN. This one, for example, is connected to Verizon. So you can input all that through a configuration tool. Whereas typically in a Linux environment, you're going out to GitHub or you're writing some kind of Python code to develop all of this. In our gateways, we provide a utility for all of that. And then finally, what I would say you recognize the most in IoT is it's not a one company solution that usually is deployed, and you end up having a combination of software. Moxa maybe for configuration, maybe you write some custom code for a very specific application that you have, and then there's software that Travis is going to get much further into, referred to as Ignition Edge. This provides a lot more additional functionality for that IoT application. So I think that brings us to our second poll question here. Thanks, Scott. So if you guys don't mind clicking your top question or concern as it relates to IoT. So these kind of match to the topics I just covered: edge connectivity, long-term support for hardware, long-term software, security, and product integration. Give it a couple seconds, and Scott, if you want to go ahead and reveal for us. Okay. Interesting. Long-term software availability does not seem to be the hot topic, but it's a pretty good mix of the rest here. So edge connectivity at 26%, security at 26%, and I'm not sure if you were able to select multiple or just one here, but it does seem that across the board, these are all pretty high concerns of the audience, so thank you. Okay, so as I wrap up my portion here and hand it over to Travis, I'll just quickly kind of review these architectures. So again, if you look at all those questions and concerns, they're applicable to all three of these. I think where we've seen the earliest adoption of IoT is edge to cloud. What I would say is coming very quickly behind that is what Travis will go into much greater detail on edge to modern SCADA. That is starting to move much faster to market with these new technologies that are now available. And then finally, edge to traditional SCADA. So even if the SCADA system in your automation environment is not changed or impact, many times customers don't want to mess with the control network and the PLCs that are controlling the equipment, but you still want to gain the benefits of some of the machine learning or analytics or just capturing that data off of your tools. It can still be done on the back end of the SCADA system. So with that, let me go ahead and introduce Travis to tell you a little bit more about inductive automation and Ignition.
All right, well, thank you, Kerry. Well, hello, everybody. My name is Travis Cox, and I am the co-director of sales engineering here for Inductive Automation. And in that department, we work very closely with a lot of customers in having to figure out how to get to these IIoT architectures and to be able to deliver information to it and have a really good operational system, but as well get that information to the cloud to start taking advantage of some of those higher level systems like machine learning tools and analytics. And so it really is a combination of understanding the hardware and the software realms, as well as looking at the protocols and the way that we get data around. And it becomes a really critical part of this digital transformation. So whatever you call it, Industry 4.0, internet, the industrial Internet of Things, we're all faced with it, and companies are trying to come to grips with what this really means and how to get started with it, and how to do it in parallel with the systems that they already have, because it can be very expensive to completely rip and replace everything that is there. So as Carrie talked about, looking at selecting hardware and the questions and concerns in that arena, I want to focus more on the software pieces of it, looking at SCADA, the operational tools, and of course the protocols in that realm. So first and foremost, we can certainly see the promise of digital transformation or IoT, the ability to get all of our operational data into these different cloud IT systems for all kinds of amazing analysis, business intelligence, machine learning, and a lot more. The real problem, though, is that there's an elephant in the room, that most organizations are trying to drive digital transformation from the top down. And if you try to approach it in a way that doesn't work for the guy working on the plant floor, your transformation efforts are going to go nowhere. And we really have to look at it from the operational side up, because that world is a very complicated world. And when you look at a lot of these cloud platforms, they just will draw a single line down to the plant floor, and we're going to get access to all this amazing data. But as all of us who are involved in SCADA, those kind of systems can be, if we turn SCADA into middleware, can be very brittle, and we don't want to add more poles to our cycles. We don't want to, to ever disrupt or get the SCADA system not working. So the thing here is we really have to look at it from the operational level first. It's got to go from the OT level up. If we can solve that level and get data to more kinds of applications, have a superior operating or SCADA solution, then we can start really addressing the needs of getting data to higher levels. And no, we have to juggle the two realms, but we really have to focus on that plant floor, because when you look at it, there are out there hundreds of different protocols, different polling PLCs. There's a lot of different physical communications, from RS-232 to RS-485, Ethernet, different infrastructure topologies from cellular to VSAT to radio, proprietary mixes of different kinds of applications, a lot of legacy device knowledge, different data formats, and of course security becomes a big concern no matter where we are. And this is the brownfield world that we live in. It's not as simple as, oh, we're just going to get all this data and just deliver it to somebody. We have to be able to look at it from a new architecture standpoint. And our journey really starts with putting together a migration strategy that gets us from the brownfield world to the digital transformation world that still continues to meet all of the OT requirements that we have. And so when we look at the steps to digital transformation, these are steps that we have here in Inductive Automation, along with a lot of other vendors like Moxa, are trying to educate on how we can actually get to this kind of digital transformation. And it starts with first being able to decouple devices from applications. And this is probably one of the most important things. We got to stop connecting devices directly to applications and instead connect devices to infrastructure. And we're going to go into this a lot more detail, but when you think about SCADA, we will make connections directly to all of these different PLCs. They have their different protocols. And so your SCADA system might have hundreds of connections to different PLCs, lots of tags that are brought in so that we can use that in the operational world. But that kind of connection gives us challenges when trying to get that data to higher levels. So the second thing is to provide a superior OT solution. So if we're going to decouple our devices from applications, we got to make sure that the SCADA system continues to meet all of the needs of the operators, and or it's going to be a non-starter. We have to know the state to the PLCs. Can we trust those values? We want extremely fast rates coming in. All these things are really important. So we have to be able to provide a superior OT solution while we can then get that data to other kinds of systems. And we also need, of course, a single source of truth. We can't continue to do mappings in every application. Connect to the equipment, do a mapping for what tags are in there. Because if we ever have to change those things out, we have a lot of places to go and modify. It needs to be one place that's closest to the device where we define the information, the single source of truth of that data that we're going to bring up to our infrastructure and our enterprise. It needs to also be plug and play. As we look at the world of IoT, we can go and buy new sensors and new PLCs, new equipment. It's not about replacing the entirety, it's about using best in class. We have to be able to plug those into our infrastructure and take advantage of them immediately without having to go and do a lot of, again, connections and mappings and things that can be very complicated and can have a potential user error. If we can do all that, we can eliminate cutovers. It can allow us to upgrade PLCs or applications without having to take down the existing system or have these costly cutovers that don't work. And so having a more modern architecture gives us a lot more flexibility, allows us to scale and to really realize the benefits of digital transformation. And lastly, we have to have licensing models that are conducive to scaling. We can't continue to pay for every single data point that's out there if we want to bring that information to more places. So licensing models from a software perspective really have to be unlimited. And then, because we obviously have to have the software on these hardware solutions at the edge, but we need to be able to get out a lot of that data that's out there. And if there's more that comes in, we can bring more of that data in without having to pay for new licensing there. So these are really 6 important steps for this digital transformation to get to the promise of where we can go with this data. So let's first look at, to kind of give a sense of what we're talking about with this new architecture. We talked about the conventional architecture here, where we are simply connecting applications to devices. And you see this here. We've got many applications: SCADA, MES, big data analytics, potentially ERP, and all those can have connections to different devices. Now, sometimes we can't do this because the PLC only supports a single connection, and oftentimes we make SCADA the middleware, and SCADA is not designed to be the middleware there. And so from an architectural standpoint, this is really not the best way to go about it. As I mentioned earlier, we want to be able to connect devices to infrastructure. And the way we do that is to have devices publishing data to message-oriented middleware, such as MQTT. We're going to be talking a lot more about that here today. That is an open protocol that is a publish-subscribe methodology where we can have the PLC sensors and the data publishing its information to a MQTT server, the middleware there, that then there can be many consumers of the data who can subscribe and get access to it. And as it being an open standard, we can have a lot of collaboration, a lot of different solutions that can be publishing and subscribing to this data. The important piece about this is that the applications don't know who the end devices are. The PLCs don't necessarily know where all the data is going to be going. And so by having that decoupled nature, it allows us to swap things out, to introduce new things, very easily. And there's a lot of benefits that we're going to go into with MQTT. But this kind of architecture is extremely important. And I know that we're in the brownfield world. We have a lot of these PLCs, of course, that don't support MQTT, and that is the solutions that Moxa and Ignition can bring to the table today to get to this kind of architecture. I'll be talking more about that. But I want to make a point here about open standards. For many years, there's when new devices come out, there'd be another protocol, that'd be proprietary, that the applications have to understand. And the more that we have these proprietary or the different kinds of protocols, and the more protocols we have, the more complex, the harder it is for interoperability and for plug and play kind of architectures. So what we're really talking about is is a system that supports all 6 of these factors. The ones that we have using open standards, it's all standards based, that are widely adopted by both the hardware vendors and the software applications, so that there's a lot of interoperability between these. It's very collaborative, it's very transparent, and very easy to get started with all of this. We can't have protocols that are really complicated. Got to have things that are simple, and we have efficient ways that we can move that data around within an architecture. And this is one thing that MQTT really does bring to the table. So MQTT itself is an open standard. It was actually developed 25 years ago in the oil and gas arena when they went to VSAT technology. We had to bring data through the satellite in a more efficient way. We couldn't do polling because that could be quite expensive. So the idea of MQTT from the beginning was to decouple the devices from the applications is a one-to-many relationship where we can take that device and publish its information up when that information changes, and then we can have consumers of that. But MQTT is an OASIS standard. It is the dominant IoT protocol, which we'll talk more about as we go along here. And there's also a payload specification for the format of the data that's being transported. It's called Sparkplug. That is also in an open standard. That's the Eclipse Tahoe project. And the reason I'm bringing this up is that as a standard, it's one that any organization, whether it's software or hardware, can adopt and can easily bring into their products. And MQTT really became famous or became big when in the consumer space, where Facebook on Facebook Messenger used that for that program to send data around, as well as Amazon with the Echo, that uses MQTT as well. Of course, now we're seeing in the industrial space a lot of use of MQTT because of the benefits that it provides. So let's talk about those benefits. Why are we talking about MQTT? Well, first and foremost, because of the publish-subscribe methodology and the broker, that's the server that's in the middle, we can decouple our devices from applications. The second big piece about it is it's extremely low bandwidth. It's a very simple protocol, low bandwidth, the 2-byte header, the rest is the payload. And the Sparkplug specification makes that payload very small as well. And we're only sending data as it changes. So it's RB, report by exception. So from the edge, data is only being published up when that information has changed. That then will be delivered to all the consumers who are interested in that information. Now, security is a huge concern, of course, for transferring information, especially if you're going to be going to the cloud. And the MQTT protocol rides on TCP/IP, and so it has TLS security. So there's encryption with certificates that we can use there. It's also outbound connection only. So it's a remote originated connection. It's connecting out, and there's no inbound firewall rules that need to be open. So it can protect our local networks while being able to get data in higher levels, and the protocol is bidirectional. We can do command writes that go back to PLCs. At the same time, it has stateful awareness. This is probably one of the most important things, because if we're in a SCADA system, we have to know that we can trust the values that are on the screens. That we know the quality, we know the state of the connection to that PLC all the way through. And while the protocol is it decouples everything, the applications and the devices understand this connection, understand this state, and guarantees that we know what's going on. The other big part of it is that it can provide single source of truth, because if we're pushing, if we get a new sensor that comes in that's brand new, we buy it, it supports MQTT natively, then there's absolutely no mapping whatsoever in that case. The device has the data that that we need, and it's going to publish it up, and then applications can automatically discover that data. And that's a big part of MQTT, is auto discovery of tags and the data from the application side of things. Now, of course, we're in the Brownfield world, and we have these legacy polling protocols where we do have to know what addresses we're trying to read. There is going to be some mappings there, but we're going to push those mappings in a single place to the edge of the network, and we're going to be able to publish that up where then everybody can consume it and get access to it. So in both cases, we're providing that single source of truth, from the edge, and the mapping is there done once, if at all, and all these consumers can take advantage of that, and we can really start looking at what we can, the kinds of things we can do with that data. And the biggest part is plug and play functionality. Because of the auto discovery nature of MQTT, because the fact that I can publish all of my interesting information to that server, we can purchase new equipment, we can replace equipment, we can do all of this very easily, plug it into network, and all the consumers are going to can get access to that data. Now, as I mentioned before, just to kind of a proof point of MQTT, it is the dominant IoT protocol. The Eclipse Foundation does a survey, and it's the top two have been HTTP and MQTT. As you can see over the years, MQTT has been leading that, and it continues to go up. This one here goes 2019 survey has very similar results, with the trend going even higher. And and we're talking about IoT here. That's not just industrial Internet of Things. This is the Internet of Things, and MQTT is that dominant protocol. So it's becoming the most widely used protocol out there. And the more applications and devices that support it, the more interoperability we have across the board. And so that is so key to these kind of architectures, to the kinds of things that we can do with the system. Now, what I want to do is kind of give you a sense of why these open protocols are so incredibly important. And I can do that by equating it to the Internet of People, which is all of the applications that we use in our personal lives, from Amazon, from Google, from Apple, Twitter, all the things that we get to use on our smartphones today. All of this has evolved through two important open technologies, and that is HTTP as the message transport, and HTML as a definition of what has been transported. And think of all the amazing things that we're able to do and utilize in the web with all these applications because of these two open technologies. It gave these companies the ability to innovate without permission. They can use these open standards, and it was, again, widely adopted everywhere. And what I'm trying to do here is explain that for the industrial world, and getting these applications and the data that's there, we are equating the Internet of People to the Internet of Things. And so for the Internet of People, it is HTTP and HTML. For the Internet of Things, it is MQTT and the Sparkplug specification, which is, again, that open payload specification for what is being transported. So MQTT is the transport mechanism, and Sparkplug is what is being transported. And think of the potential and the ability to empower open innovation, and again, to have all these companies who can innovate without permission by just simply using these simple open standards that are widely adopted and used. And that is something that both Moxa and Inductive Automation, we have fully integrated with MQTT, because we see this as a very important step in this architecture. So, of course, we have to get there from the brownfield world, and this is where we'll talk specifically about the solutions we're coming here today with. Moxa's equipment, the hardware, as you see, there are concerns both on just getting the hardware out there at the edge of the network, and then the second concern, of course, is the application, the software that rides on that hardware, to get access to the equipment, the PLCs that's out there. And again, in the brownfield world, that's the world we live in. How do we get to this new architecture from there? And that is where we can deploy the Moxa hardware with Ignition Edge. We talked about that earlier. Ignition Edge is a software that would run on that equipment that has drivers to PLCs, or Allen Bradley, Modbus, Siemens, Opta22, SnapPack, DMP3, and more, and can bring that information and do that protocol conversion, publish it to an MQTT server. It could be on-premise, or of course it could be in the cloud, and we can do that securely. And so the idea is that we can put these edge gateways in front of our PLCs, and we can start doing that slowly to transform our architectures to a more modern architecture, where then we can use modern applications, modern SCADA, to be able to take advantage of it. So that's an important part of MQTT, is once we bring it to that server, there are many applications, from business applications, of course, to SCADA applications that can consume and do a lot of interesting things with that data. So think about it, from not only from the brownfield world, but from the new equipment that we purchased. We have a lot of OT data that's out there in the field, and in some cases, up to 90% of that data is stranded in the field, and we want to get access to that. We want to bring it in to our infrastructure. And so if we can put these edge gateways in place, or if the device could support MQTT natively, no matter what, we're getting all this OT data, we're publishing it up to through infrastructure, over these different mediums, Ethernet, VSAT, cellular, to an MQTT infrastructure, and we can do that securely. We then have, an architecture in place where then we can consume and do a lot with that data, and have this auto discovery and the ability to innovate, do new things, test out new technologies by getting access to that real information. So that big access to big data can provide some real big value. So once I get that data published into that MQTT server infrastructure, I can plug in Ignition Central SCADA, and we can do a lot with it from a SCADA perspective. We can also get information to other systems, more protocol conversion type stuff there. We can plug in another system to bring data directly to the cloud. Remember, we want to bring it to Azure, or AWS, or Google Cloud, or IBM Watson, things that Carrie was mentioning before. So we can start taking advantage of machine learning analytics. Once we solve the OT problems, we can start delivering information to these higher level systems. We can go to ERP or other OE and MES systems, or asset management systems, or whatever it might be. Any future apps that we have, we can start plugging into this infrastructure. And could you imagine being able to plug a new application into the infrastructure and discover the thousands of devices, potentially millions of tags, in a matter of seconds that are automatically discovered there, and that you can do awesome things with? And as you plug in new stuff, it automatically comes in there as well. So this is the kind of innovation that we can get to, and this is possible today. And it really starts at the edge. The edge is a critical piece, which is why we're trying to bring you those concerns from both a hardware and a software perspective. Now, of course, security is always a big concern here as we look at these kind of architectures. PLCs, or legacy PLCs with these polling protocols, typically are the weakest point of control system, most vulnerable. If you were to get on that network and you knew, that protocol, you can do some harm. And so one thing that this edge connectivity does, if you put them in front of the PLCs, it can protect those PLCs. We can take it off the main control network, put it behind an edge gateway, have data being published up through that TLS security that uses encryption and certificate authorities, and that is outbound only, so we can block those inbound routes. By doing that, we can offer more security within our OT infrastructure. And we're trying to solve that through pure networking solutions, but as we get new equipment that supports MQTT, it'll just natively have the security. But with these legacy equipment, we can offer another layer in front of it that can help us. And once we publish that information infrastructure, we can have lots of consumers. So in particular with Moxa equipment, we did some testing on the Moxa UC80-100 cellular gateway, where we're running Ignition Edge and connected to various PLCs with different protocols. And we're bringing that information up to an MQTT server that we can then look at from a SCADA perspective or other business application perspective. And we wanted to see, what kind, if we had this single piece of hardware out there at the edge, how much could, how many tags can we bring up? How much can we push through, and with its low bandwidth through a particular, medium to the network? And so this is where we did some testing, and this is, Ignition's licensing is unlimited. The limitation is going to be hardware. So we want to know what is possible there. So we did two tests: how many tags can we load, and the second is, if we're publishing that data to a central system, how much can we publish, per second? And of course, we always do worst case testing where every tag was pulled at the PLC at a 1 second rate, and every single value was changing every second. So when you do that, you can see what the real maximums are, where then in the real world, as we pull things slower or that values don't change as often, we can extrapolate that to these two different estimates. So the first test was to get a baseline of the number of tags that the device can handle, the combination again of the UCA100 and Ignition. And you can see it taps out around 6,000 tags, that we can handle there on the single equipment, right? So one edge gateway with Ignition running, again, all on Linux there, and pulling 6,000 tags at 1 second rate, every one of them changing every second. as you can see, that's where we about tapped out on that. You can kind of see it was more the CPU than it was memory in that case of the equipment. Now, if we look at that from a real world perspective, we can get upwards of 25,000 tags. We're polling at 5 seconds, out at the field. Rate of change may be being 10%. It's pretty standard for industrial data. And you can see that that's really only about 500 values per second that we're transporting. We can even do more than that. As you can see, the way we figure out the rates and the rate of change in the dead bands can really allow us to get a lot more of that tags that we can then deliver up to the central system. So if we look at this, we can start realizing the benefits of getting access to that 90% of data that's been stranded that we can bring into an infrastructure and do a lot more with. Now, this was just on how many tags can we actually poll and work with. The second test was, of course, transporting that over a network. And there's different networks, right? Ethernet networks, there's cellular networks, and there might be some real limitations on the network. So limitation could be other limiting factor, like CPU was in the previous test. Here we use MQTT, of course, to transmit that data to a central server, and a very similar type of test, but we tapped out about 5,000 tags that were changing every second there. And as you can see, in that particular scenario, we're transporting every second about 100K of data through the network. And that could be a lot, of course, in a month, but the idea is that that's the worst case, right? Everything changing there. When you extrapolate that, looking like 25,000 tags again at 5 second rate, it's really only 10K per second that we're actually submitting up. And we could even further refine that, especially if you have cellular plans or things you have to look at. We can refine that to make sure we can deliver that information out there, publish it when it changes up to a central system in the most efficient way that we can. So these benchmarks were incredibly important to get that baseline, to sort of see, as we do the digital transformation, how many edge gateways do we need? How can we get from that brownfield world to the new architecture there? And a lot of times, again, we can have a more high-powered machine. Moxa delivers a lot of different kinds of equipment. We used one that was an ARM-based processor. There's x86 processors that have more power, so we can get at more of the tags. And so you have to look at those two components. And ideally, you don't want to deploy thousands of edge devices everywhere. You want to be able to do it in a cost-effective way, but to be able to get at all that data out there. And so these are the questions that we commonly get to figure out how we can migrate and do it in parallel and do it in the most cost-effective way. One note that I want to mention here about MQTT is that Moxa's equipment actually with ThingsPro supports MQTT Sparkplug natively, and they have a Modbus driver there, and a lot of these different equipments will support Sparkplug natively. And if it's a PLC or sensor that supports MQTT, perfect, because then there's no need for any edge gateways like Ignition to poll and to do those protocol conversions. It already supports it at the edge of the network. But then there are these different polling protocols, and sometimes the equipment will be able to communicate to that PLC directly, poll it, and publish through MQTT. And ThingsPro does that for Modbus in particular. With Ignition being on that equipment, then we get access to a lot more of the drivers. There's more drivers that Ignition supports there. Plus, Ignition can be managed centrally. There could be over-the-air updates and central administration. There's store and forward of that data. And by the same token, out there at the edge of the network, if we needed a local HMI on a touchscreen computer, having Ignition on that equipment can provide that. So the idea is that you get this dual-purpose hardware. One thing to have to manage out there that's ruggedized, can be in an industrial cabinet, very easy to maintain over time, and gives you that long-term support, both from a hardware and a software perspective. You really can start innovating and doing a lot of cool things with it. And looking at this from now a new version of Ignition, the kinds of applications that we can deliver to people, the things that we can do with that data once we bring into the infrastructure. And our new release of Ignition 8 opens a door for more visualizations, more ways we can present that data to people, and more optimization so we can get at more tags because the licensing model is unlimited. And so one of the things that Ignition 8 brings to the table is a new module called Ignition Perspective, which is visualization that's native HTML5 and CSS, pure web, no plugins needed whatsoever. And so you just simply go to a browser, go to a URL, and you can see the application Of course, it has high level of security and customize. You can customize it, build things that you want with the designer, but it's delivered in that medium. It also, we also, not only can we do it in a browser, HTML5 and CSS, where there's native apps for iOS and Android, that we can have true mobility on our phones and tablets, which is important for the new workforce coming in, that they expect to use their phones and tablets. And with that, we can get access to the phone's amazing sensors, GPS, accelerometer, camera, and there's a lot of cool things that we can do with that as we go forward. The perspective is built mobile responsive as well. So you build one project that would look good on a desktop, a tablet, and a phone. And you see this in, if you go to websites out there, you'd see them transform as you change from one device to another. And it's the same concept that we can bring into HMI SCADA that we can build into the designer, and we can customize our own way. Without having to you don't have to understand the underlying technologies that are there. We're using a drag and drop designer to build these kind of applications. So allowing us to bridge to these modern technologies and to bring our HMI SCADA up to another level, without having to build everything from the ground up. It's the product makes it very simple to attack this. With all the optimizations, we can have a lot of clients, a lot of hundreds and hundreds of people looking at the data at the same time. All of that is a push notification, just like MQTT's push publish by exception for the Ignition runtime clients. That data is pushed to that client when it changes from the server, so we can optimize our communication and get data to more people. Again, with the apps for iOS and Android, we can do a lot of cool things with those sensors. So as an example, as we walk around our plant, we can have the GPS that could switch our screen on the application to where we're at in that plant. We can go scan a barcode that's online to get information about the machine, or to go navigate to that particular place of the application, or maybe for inventory control or whatever it might be. We can take pictures of things if we are trying for troubleshooting and tagging our location while we're doing that. There's a lot of opportunity that is there by being able to leverage these new technologies that we're so accustomed to in our personal lives. So the idea is that we're going to be easily building these kind of mobile applications and get that information to more people once we get that infrastructure solved and we get the data to different kinds of applications that are out there. I want to make one point of security. Security is always fairly important when looking at this, and we use tried and true identity management with the new version, which is really important. Companies are using these different identity systems that provide single sign-on and two-factor authentications. So we know who that person is when they're logging in. Again, providing high-level security all the way around is extremely important. So what I thought I'd show you real quick, just 1 or 2 minutes, is a demo project that kind of showcases the perspective application. So we're going to be going here to a browser that is pointing to demo.inductiveautomation.com. And so this is a demo project that, again, is Ignition Perspective, all built in Designer, very simple and mobile responsive. So if I go look at an HMI screen in particular, so here we can see an HMI, and a couple different versions of that, kind of high performance version, as well as a kind of classic HMI, and then like a little dashboard at the bottom. Of course, we can see values, we can do control, but this was built to be mobile responsive so that if I'm on a phone, you get a sense of what that looks like. If I'm on a phone, I'll switch it to like a phone size here. Then you don't want that process screen to get scrunched. It's too much you want to be able to have it optimized for the phone. And here you can see I'm looking at the same data, more of a vertical fashion. And so there's a lot of different kinds of things that we can bring and deliver to people in the browser. As you see, HMI, there's all sorts of different kinds of components that this provides, but of course history and looking at charts that are interactive charts, looking at tabular data there. So here's some history, as well as looking at various KPIs. So say like the alarming system, we want to see some various KPIs, alarming system here, alarms by hour, alarms by frequency, by duration, really get a sense of what's going on. All sorts of things can be delivered to this, and these are interactive applications. We can write information back, and then we can fully take advantage of all that data that we're bringing up. So with that, let's my part is concluded, and we're probably going to the questions piece here, but back to you, Scott.
Great, thank you, Travis. So this is actually the point where we'll go through some of the questions that came in through you guys, and we'll answer them as quickly as possible. Quick time check, we have about 5 minutes to do so, let's just dive in. All right, the first question looks like, Carrie, this is for you. What applications and industries are moving fastest with IIoT solutions?
Okay, can you hear me okay?
Yes.
Yes.
All right, perfect. I had it on mute there. So that's an interesting question. We definitely, I would say in the IoT space, because it is such a cross-vertical technology, we certainly look at applications and architectures, I would say even customer types, maybe a little bit more than verticals. But in my opinion, I think the early adopters are probably the machine OEMs, so manufacturers of equipment that are highly distributed. And so the ROI, I think, is such immediate to be able to get remote connectivity and start getting data back to the servers that I would say highly distributed architectures, OEM type customers. If I had to pick a vertical, I would say oil and gas, because there are so many heavy industrial pieces of OEM equipment, would probably be the top one.
Great, thanks, Carrie. The next question, Travis, when would you recommend Ignition Edge versus a device that speaks Sparkplug natively?
Yeah, that's a good question. So, like I was saying earlier, there are now, vendors, hardware vendors, PLC sensors that are supporting MQTT Sparkplug, and like from a PLC perspective, you have a PLC that can, do the automation, but can get its data to an MQTT server. There's no need for any mappings, no need for any additional software for the edge. It is going to be right there on that equipment. And that's the greenfield world, right? And so as we get that new equipment, look out for those kind of open technologies so we can easily have that plug and play. But in the brownfield world, there's a lot of different PLCs out there that don't support MQTT or do not have firmware updates that will give you MQTT. In that case, that's where edge devices that speak Sparkplug natively or software like Ignition can do that conversion, can get that into an infrastructure. And Ignition itself provides some additional benefits with the vast amount of drivers that it has. It's completely Linux based, or any operating system for that matter. And again, other equipment like some equipment supports Sparkplug there on its own, and you can use those. So it's really figuring out the solution and making sure that we're doing it in a way that gets that data to the infrastructure in the most cost-effective way that we can.
Okay, thank you, Travis. We'll try and get through two more. Carrie, what cloud solutions is Moxa planning to support and integrate with?
Okay, I'll probably take the easy option there and say all. I think it depends on the specific integration that you're looking for. So being able to just publish data to the cloud is really not that difficult. And certainly, I would say from Moxa's perspective, we don't try to pick one cloud over another. Where it gets more interesting, if you want to talk about integration and more specifically integration at the edge, we have certainly done the most to date with a formal partnership with Microsoft. They do have a software product called Azure IoT Edge. And when you look at the integration of cloud provider software on the Edge Gateway, then there is more software compatibility. There's more technology handshaking that you want to make sure is possible. So I'd say Edge cloud partner integration, definitely we're the furthest with Microsoft, but we have customers that use AWS Greengrass, Google, IBM, all have various products. So easy answer, I would say all, and we'll continue to do more integration with each cloud partner and their specific Edge software.
And I'll add a note that each of those cloud providers support, MQTT, have the infrastructures like this. And so it can make it really easy to be able to choose any one that you want because of this open standard.
Yep, good point.
All right, thanks, guys. So we have 1 minute. Last question. Travis, with the launch of Ignition 8 and perspective for HMIs, do you foresee local panel PCs being replaced with web UIs?
Yeah, that's a great question. A lot of customers are faced with that question today as to which route they're going to go down the path of, and we're just so used to HMIs being very protected and they're not using a browser, right? Just not getting access to the operating system. But that is changing. I mean, the browsers are really mature technologies. They're certainly available for the industrial use. We will see, I think, a natural progression of just simply using the web for everything. And of course, we'll want to make sure that we can do that on this equipment that's full screen, that just makes it just so that application is the only one open. But all these kinds of things, running browsers and kiosk mode, that all exists. So I think it'll be a natural progression here as we move forward, and as people are getting toward just this digital transformation using more modern systems.
Great, thank you, Travis. So unfortunately, that's really all the time we have. There are other questions that we didn't have a chance to get to, but I do want to thank Carrie and Travis for sharing their expertise today. If anyone does want to get their questions answered, you can send us an email directly to usa@moxa.com. With that said, we're all done. Thanks again for joining, and have a great rest of your day.